See, all a sequence means is an ordered list of numbers. That's all a sequence means, is that you have a list of numbers and they're in a specific order. Some ways that we can talk about the orders, we can talk about it in terms of terms. Ugh, that's a terrible sentence. But we can talk about terms. More specifically, if I'm talking about my first one, I'm going to call it my first term. I'm going to call my next one my second term. I'm blowing people's mind, I think. My next one's going to be my third term, and so on, until you get to your end, which would be your nth term, or maybe it doesn't have an end, it just goes on forever. So that is one way to talk about it. So now I can say third term, and Liam would say that's 6. If I said the fourth term, then someone would say it's 7, and that way we could talk about it. The other way we could talk about this is using notation. We can use some notation. Yeah. And specifically, A sub something. It could be B sub, it can be C sub, it can be C, D sub, whatever you want, letter sub. And my first term would be A sub 1. If my first term is A sub 1, my next term must be A sub 2. And then my third term would be A sub 3, and we would keep going. And in fact, we'd go until we get to A sub n. I think the most important part about this notation is this A sub n, because we're going to talk a lot about A sub n minus 1, A sub n plus 6, so on and so forth. I personally believe that the easiest way to deal with these A sub things is to put it in plain English what you're talking about, rather than plugging in numbers and seeing it's 3 minus 1 equals 0 or something. We're going to talk about this in plain English. So my note down here is how to think about this in terms of just plain English. If I start with a term called A sub n, so we don't know what number it is, we just know it's A sub n. That is our starting off point. So it could be A sub 4, it could be A sub 5, could be anything. We start with A sub n. If I ask you about A sub n minus 1, what I'm really asking you for is the previous term. I'm asking you for the previous term. Because whatever this n is, say this n is a 6, then A sub 6 minus 1 is 5. If I was talking about the 6th term, now I'm talking about the 5th term. So this is just the term before. So n minus 1 tells me the term before. Well, that means n minus 3 is going to be the 3rd term before. The 3rd term, let's just call it prior so it fits in there. Once again, if I was talking about my 8th term, that would have been A sub 8. 8 minus 3 is 5. That would be my 5th term. That's 3 before it. A plus 5 then, or A sub n plus 5 would be 5 terms after. So it would be the 5th term after. Let's put a little example down there. Let's put a little example of what I'm talking about. Let's say I'm talking about A sub 3. First of all, an important thing about A sub 3 is my n would have to equal 3. Because I'm replacing 3n for this n, so my n equals 3. Well, if I'm talking about A sub n minus 1, in common terms, if I know it's just the term before, I automatically know I'm talking about my 2nd term. Just in plain English, if this is my 3rd term, the term before is my 2nd term. If you want to go the mathematical route, this would be A sub 3 minus 1 equals A sub 2. So it would in fact be my 2nd term. If I said find your A sub n minus 3 value, you would say that's 3 terms prior. It's going to look a little weird mathematically, and that's why I like to think about it first practically, and then mathematically, because mathematically it's going to look like this. A sub 3 minus 3, which equals A sub 0. That is possible. Your very, 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 very first number might not exist. This might go forever in this direction. This might go 4, 3, 2, 1. We just can't see it. And so if this is a sub 1 equals 4, a sub 0 might equal 3. A sub negative 1 would equal, but I like to think about it as just three terms prior. 3 terms prior. And the fifth one, the last one is your fifth term after. So if I'm on my third term, I should come up with the eighth term. Let's see. So we have 3 plus 5 equals a sub 8. And it is, in fact, my eighth term. So whenever we deal with these, if you ever get really confused with what I'm asking you about, just see if you can put it in plain English. Sometimes that plain English can make your life a lot easier. All right, the last statement here is sequences can be infinite or finite. So either this can go on forever, it can go 4, 5, 6, 7, 8, 9, 10, 11, forever, or it can just end. Finite would be it has a start and end point. Infinite just means either or both ends go on forever. Finite, stop and start. Infinite just means either direction or both go on forever. All right, there's 2 ways to write sequences. And the first way is a recursive formula. Our recursive formula, which is just a sequence in which each term is based upon the previous term before it, which means you have to know the term before it in order to move on. So my example here is write the first 5 terms. A sub 1, that just means that's the first term I'm looking for. So I'm going to, on this problem, I'm going to immediately write a sub 1 equals negative 2, and I'm 1/5 of the way done, since I just had to find 5 terms. Now let's look at this next thing. The next thing says a sub n equals n plus a sub n minus 1. Well, the way I think about this is a sub n is the term I want. This n is just already given to me. We'll see that. And so a sub n minus 1, since I started with n minus 1 would be the term right before it. So a sub n minus 1 is going to be the previous term. I'm going to kind of build a wall here so I don't accidentally go past it. And in fact, what I'm going to do is I'll move that a sub 1 over just a little bit. You should have plenty of room, but I got to write a little bigger than you. All right, my first term is negative 2. All right, we are going to do the strictly mathematical way right now. We're going to do my next term is a sub 2, which means my n equals 2, which means I can replace all of the n's in this statement with 2's and go from there. So this would be 2 plus a sub 2 minus 1, which would be 2 plus a sub 1. Then I would figure out what my a sub 1 equals. Well, that equals a negative 2. So in fact, this is just going to be 2 plus a negative 2, which equals 0. I'm going to do a sub 3 the way I'd think about it more naturally. So a sub 3, and I'm going to write out exactly what I'm thinking. Well, a sub 3, well, our n equals 2, or 3, sorry. So we are going to have 3 plus. Now, rather than actually plugging this 3 in for this n, I'm going to just think about this in my head. And this is what I'm thinking about in my head. Well, it's 3 plus the previous term. I probably wouldn't write that because it would be repetitive to write previous, last, next, 3, prior. But I'm just going to say it's 3 plus the previous term. Because now in my head, I'm just saying, well, it's 3 plus my previous term equaled 0. So that just equals 3. And this will make your life a lot easier because 4 would just be, well, my n equals 4. So we are going to have that equals 4 plus my previous term is 3, which should equal 7. I know it says find the first 5, but we're okay at 4. I think 4 gets the idea across. So if it really confuses you, these a sub n's and stuff, just say it in plain English. All right, our next one. We have a first term, we have a second term, and then we have this statement here. If you just have a statement just hanging out like that, it is automatically assumed we're talking about a sub n equals a sub n minus 2 plus 3 times a sub n minus 1. So let's say this in plain English. Well, a sub n minus 2 is going to be 2 terms before. So 2 terms prior, or 2 terms before. And this a sub n minus 1 is going to be 1 term before. Well, if I have to list my first 5 terms, we already got 2 down. A sub 1 equals negative 1. A sub 2 equals 1. 2 of the 5 are done already. You just have to be able to write it down, and you have to write down your first 2. Show me that you understand those are my first 2 ones. All right, then we're going to go on to a sub 3. Well, a sub 3, we said here is going to be 2 terms before. Well, 2 terms before my third term is going to be that negative 1 plus 3 times the term before, which is 1, which is going to equal negative 1 plus 3, which is going to equal 2. Yeah, Charlie. The negative 1 comes from, so see, that's why I write this in plain English. I have a sub n minus 2, and I'm going to say in my head, this is 2 terms before. So we have 3, so 2 terms before my third term is my first term, which is negative 1. And our next one is 3 times the term right before it, which is that 1. Does that make sense? All right. If you ever get lost and you can't say it in plain English, you can always go back to just plugging in your n values and just going. This is a completely valid method. All right, this is 100% valid. So I could have plugged a 3 in here, and it'd be 3 minus 1, which would be a sub 1. A sub 1 equals negative 1. In fact, how about we do it for the next one? Just to show you that it is still possible. So if I was talking about a sub 4, I could do it the strictly math route, where I would say, well, my n equals 4, so we'd have a sub 4 minus 2 plus 3 times a sub 4 minus 1. Well, that would equal a sub 2 plus 3 times a sub 3. I'm going to slowly run out of room here. But that's going to equal a sub 2 would be 1 plus 3 times that 2, which would equal 7. Although it takes a little more space, completely doable. I like the method where you just kind of say in your head what we're talking about. So that's how I'll do the 5th one, because I'm going to do the 5th one on this one. My 5th one is going to be the term, or 2 terms before the 5th one, which is going to be a sub 3, so that'd be 2. Plus 3 times the term before it, which is 7, is going to equal 21 plus 2 is 23. So ultimately, I would like you to be able to go right to this, where you understand what we're talking about terms. But you can fully do the math. Questions on recursive formula? The recursive formula is technically usually the easiest one to find. It's the easiest one to replicate because it's just talking about which terms we are talking about. All right, we're going to move on to the explicit formula. The explicit formula is generally the hardest one to deal with because we actually have to create explicit formulas based upon numbers. So we're going to start out talking about just what is an explicit formula. Well, remember that recursive was based upon preceding terms. You had to find your first one to get your second one, to get your third one, to get your fourth one. So if I asked you here, find your 100th term, that probably wouldn't be fun to do it all by hand. What explicit is a sequence in which each term is based as a function of n or placement in a sequence. So it is not based upon previous terms. Not based on previous terms. It doesn't look something like this. A sub n equals n squared plus 1. So as soon as I know what my n value is, I can solve it without having to figure out terms before it. So we have a sub n equals n squared plus 1. I didn't put in, I'm not missing any notes that I thought was key here, am I? No. All right, so we're going to write the first three terms of this. So my first term is going to be a sub 1. Well, that means my n value equals 1. So I'm going to replace 1 in for that n on the other side. So we just have 1 squared plus 1, which equals 2. My second term is going to be a sub 2, which is going to be n equals 2. Which, once again, I'm going to replace all my n's with 2. So we'll have 2 squared plus 1 equals 4 plus 1 is 5. And the last one I have to do is a sub 3. Once again, my n equals 3, so we're just going to have 3 squared plus 1. 3 squared is 9 plus 1 is going to be 10. The next one has something really important in front of it. See that negative 1 to the n minus 1? That's a really, really powerful thing in sequences. That right there is going to trip up several of you on the test, and we're going to talk about it in several lessons because it is a key part of sequences. This right here, this negative 1 to the n minus 1, all it does is it alternates between positive and negative. That's all it does. Because negative 1 to the first power is still negative 1. Negative 1 to the second power is a positive 1. Negative 1 to the third power is a negative 1. So all this does is it alternates between negative and positive. And we'll talk a little more specifically, especially in an example today, because you want to figure out which order it is. As long as you know if negative comes first, then the next one has to be positive. If positive comes first, then the next one has to be negative. And it's a really nice shortcut just to know it's going to go bounce between positive and negative, and that's all it does. Another key thing about this problem. Whoa, that was a bit much. N must be greater than or equal to 2. Notice how so far I've been saying my first term is a sub 1. That is not always the case. In this case, a sub 1 doesn't exist because my n has to be greater than or equal to 2. So because of the fact that n has to be bigger than or equal to 2, we have to start at a sub 2. We have to start at a sub 2. Even though it seems weird, this is actually our first term. I'm going to go ahead and plug in my n. So we're going to have negative 1 to the 2 minus 1 times 2 plus 1. That's going to equal a negative 1 to the first power is just negative 1. I guess I'll do it all in this one. Negative 1 to the first power. 3 is going to equal a negative 3. As soon as I have that negative out front, I know that the negative 1 to the n minus 1 alternates between positive and negative. So my next one has to be positive. We'll do the full notes, but when you get proficient at this, you can just write negative, positive, and you can kind of skip your negative 1 there. So because it's our notes, we're going to do negative 1 to the 3 minus 1 over 3 plus 1 is going to equal, well, negative 1 squared is going to be a positive 1. Times 4 is going to equal a positive 4. And our final one we have to do is 4, which is going to be negative 1 to the 4 minus 1, 4 plus 1. It goes negative, positive. This one has to be negative, and negative 1 to the third is negative 5. And just looking at that pattern, I can keep going. It's 3, 4, 5, 6, 7, 8, 9, alternating are positive and negative. So if I made you list the first 10 terms, it probably wouldn't take that long as you can recognize patterns. And that's what sequences are. They're patterns, and it's recognizing patterns. All right, so that's explicit formula. We're going to talk about how to write an explicit formula. So writing formulas for the general term. So we're writing a formula for the general term, find the nth term, write an explicit formula. All three of those stand for the same thing. Come up with this equation. So however I phrase the question, no matter what one of those I'm doing, I'm actually asking you for the exact same information. So we're going to write just a general formula for this. In order to come up with a general formula for it, you have to recognize patterns. And I'm going to show you the 3 basic patterns that you have to recognize for your homework tonight. The first pattern is I can add a number over and over and over to create our next step. So, for example, to get from 2 to 8, we add 2. 8 to 10, we add 2. And 10 to 12, we add 2. On Monday, we'll learn this is called an arithmetic formula. It is arithmetic because I'm adding the same number over and over and over. If you're adding the same number over and over and over, everything I put in this box works for any one of them. So we have plus 2, plus 2, plus 2. I'm going to kind of build this one up, and then I'll shortcut the second one. So the long route of doing this is saying, well, a sub 1 equals 6. A sub 2 is going to equal, well, I want to hold on to that 6 because I'm trying to come up with a formula. I want to keep everything the same except for I want to change one variable. So I'm going to hold on to that 6. I'm going to say, well, the second one is just 6 plus 2. My third one, once again, I want to hold on to that 6 because I want to come up with a generic formula. That one's plus 4. And finally, my fourth term would be 6 plus 6, which equals 12, and those are all correct. Now, it's not quite a formula because I'm doing 6 plus a number over and over and over. So I'm going to add on to this a sub 1 that this is 6 plus 0 because I want to follow that pattern that I have 0, 2, 4, and 6. I want to rewrite that 2, 4, and 6 holding on to a number again. So what I'm talking about is, let's talk about this one. I can rewrite this one as 6 plus 2 times, let me put it in red. 2 times 1. This one I can write as 6 plus 2 times 2 would give me 4. And my last one is 6 plus 2 times 3. So it must mean that this first one was 6 plus 2 times 0. So our whole goal in writing an explicit formula that's general is to hold on to as much as I can from term to term to term. I held on to that 6, I held on to that 2. The only thing I can't hold on to is that 0, 1, 2, 3. But that's a pretty nice pattern, that it's 0, 1, 2, 3. And what's really nice about that is if my first term is 0, my second term is 1, my third term is 2, my fourth term is 3, look at those numbers. Well, 4 minus 1 is 3. It gives me that 3 in that bottom. 3 minus 1 gives me that 2 in the third term. 2 minus 1 gives me that 1 in that second term. And finally, 1 minus 1 gives me that 0 on my first term. So this whole column is really just take what term you have and subtract 1 from it. Take whatever term you're on and subtract 1 from it. So our generic formula is going to be a sub n equals 6 plus 2 times n minus 1. I am not going to simplify this right now. We're going to simplify it on Monday, and it has to be in the simplified form on Monday. But for today, I just want us to come up with this. Now, I don't know about you, but I don't want to do those steps every single time. So I want to show you a pattern with any one that you're adding the same number over and over and over. If you're adding the same number over and over, this is going to be known as our difference. Our difference is 2 because it repeats over and over and over. So the two huge things I want to point out to you, and it's not a coincidence. Our first term is 6. That 6 goes right there. My difference is 2. That difference is always going to go there, and that n minus 1 will always be there if it's just adding the same number over and over and over. So if you notice this pattern, all you need to know is your first term and your difference. Let's have some of that down. And you have your equation. All right, let's do the next one, because the next one's going to be very, very similar, but we're going to be able to shortcut it a bit. So to go from 7 to 13, we are going to have 6. It is plus 6. 13 to 19 is plus 6. And 19 to 25 is plus 6 as well. So this falls into the exact same pattern. It's arithmetic because I'm adding the same number over and over and over. Rather than doing that whole list, all I'm going to say is, well, my first term is 7. So my first term is 7. And that difference I was talking about, I'm just going to let a D stand for it, is going to be that plus 6. So we can go right ahead and write our formulas. A sub n equals this 7 plus this 6 times n minus 1. Yep.
Will anything change if it's a descending
Nope.
pattern? Okay.
Nope, all it's going to change is your difference will be a negative 6, so you'll plug 7 minus 6. It'll become a negative. And here's my advice to you, and I know some of you are going to take it, and the people that don't want to do well on the test will not take it. Just check to see if it works. It's not hard to check. My second term is supposed to come out as 13. So if I plug a 2 in here, it'd be 2 minus 1. This would be a 1. 6 times 1 is 6. 6 plus 7 is 13, and it would work for each of these. Just check it. It takes like a second to check it. It's the hardest thing as a math teacher is people that make mistakes and they could have caught it just by checking it. Just check it to make sure it's correct. Even if you check it and it's not correct and you don't know how to fix it, just say, Mr. Pabian, I know this is incorrect, but I'm not sure how to fix it. I can give you more points based upon that because you're showing me problem-solving techniques, and that's worth points in this class, all right? So worst case scenario, you just say, I know it's not right, but I don't know how to fix it, kind of thing. All right. So that is one type that you're going to see in the homework. These are going to be the other two types. And the first one has a lot going on in it. It has a lot going on in it because do you see how it goes from positive to negative to positive to negative? It's going to throw several of you off. All that's telling you to do, so since we're going from positive to negative, let me get to that page real quick. So if it alternates from negative to positive, or positive to negative, so this alternates positive and negative. We are going to use negative 1 to the n minus 1. These are your two basic ones. Either you're going to use negative 1 to the n minus 1, or you're going to use negative 1 to the nth power. Those are the two most common ones. And how to know which one to use and how I know here is, see how this first term is positive? Do we all agree that first term is positive? If you're drifting off the low line, just make sure you're paying attention to this one part. This is positive. My first term is positive. So if I plug a 1 into this, this better come out as a positive. Well, 1 minus 1 is 0. Negative 1 to the 0th power is positive. This is the correct one. This will give my first term positive. So this right here will make first term positive. As soon as I recognize this, I no longer care about being positive and negative. That will take care of it. I'm almost looking at this as just being 1, 1/4, 1/9, and 1/16, and I'm looking for a pattern there. Does anyone see a pattern with 4, 9, and 16, or what kind of weird numbers those are? Yeah.
It's like 2 squared, 3 squared.
Yeah, perfect. It is 2 squared, and that's the patterns we're looking for. This is 2 squared. This is 3 squared. This is 4 squared. So if I needed to do 1/1, that would just be 1 squared following that pattern. 1 squared, 2 squared, 3 squared, 4 squared. We have all the information we need to write an explicit formula for this. And that is A sub n equals, first we're going to take care of that negative positive. So that's that -1 to the n minus 1. That takes care of our alternating negative and positives. Now we know it's a fraction with a 1 on top, because they all are a fraction with a 1 on top. And now we just got to think about what's happening here. This is my first term. My first term is 1 squared. My second term is 2 squared. My third term is 3 squared. So our formula is going to just be n squared. Because my first term would be where n equals 1. 1 squared gives me a 1. My second term is where 2 is going to be squared. 2 squared is going to give me that 4. My third term would be where my n equals 3. 3 squared equals that 9. And that pattern works. Question about that? Because you will in the homework have to recognize that and know how to write this. So make sure you ask questions now. All right, next one. Next one can be tricky. All right, so just look at the next one. Don't write anything down. I'm just going to write some stuff down, kind of spitballing information. So my first guess on this one would be I'm going to check the numerator, and then I'll check the denominator. Easiest way to break apart these most of the time. So I'm going to look here, and I'm going to say, well, if I add 2, do not write this down because this isn't right, plus 4, plus 8. Those are not the same numbers, so it doesn't match these. This is a completely different case. So if you try to check for adding and it doesn't work, then you have to think about something else. The other thing we could think about is, well, this is times 2. This is times, hold off on writing stuff real quick, times 2 times 2. If you see something that looks like this, what we're going to think about on the homework, and we'll get to an easier way to write it, is what I want you to think about is 2 is crucial to this because I'm multiplying by 2. But rather than doing times 2, I'm going to say this one is just going to be 2 to the first power. This 4 is going to be 2 to the second power. This is going to be 2 to the third power. And this one's going to be 2 to the fourth power. There's a mistake on this one. I must have printed off an old edition. This 4 down here on the bottom left should actually be a 3. Otherwise, this doesn't work. I just printed off the old edition. So now we have 3, 9, 27, 81. Once again, if you're looking for patterns, you would think about, well, I'm just multiplying 3 over and over and over. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So 3 is my primary number here. So I'm going to do the same thing I did in the numerator. I'm going to say, well, this is 3 to the first. 9 is 3 squared. This one is 3 to the third. This one is going to be 3 to the fourth. So our equation is going to be some fraction where I have 2 and 3 on the bottom because the 2's and the 3's stayed constant throughout. Now we've got to raise it to a power. And how we're going to do that is we're going to look at our first term. Our first term needs to be 1's. My powers are 1's. My second term, 2's. Third term, 3's. Fourth term's 4. So we're just going to raise this to the nth power. Because if I plug a 1 in, that's my first term. That will give me 2 over 3. If I'm looking for my second term, my n would be a 2, which would give me that 4 over 9, so on and so forth. So that is our next one. Those are your 3 patterns you're looking for on the homework. All right, those are our 3 major patterns that you're looking for. All right, the last thing we have to talk about is factorials. Factorials. Factorials are telling you how many different orders you can have. That's why we talked about it when we were doing like combinations and permutations. That's why you did factorials with it. Factorials' primary use is telling you how many different ways you can organize something. So 1 factorial is just 1. There's 1 way to organize 1 element. So if I just had Liam, there's no way I can order you in a different way in the classroom. 2 factorials, 2 times 1, that's 2. So if I have Marley and Liam, there'd be 2 different places you could sit. You could both sit like that, or you could flip it. 3 factorial is 3 times 2 times 1, which is 6. So if I had this entire pod, there's 6 different ways I can organize them. And why I go through that with factorials? Because the question is always why is 0 factorial equal 1? Well, 0 factorial equals 1 comes down to, let's say this pod's empty and there's no one sitting there. There's only 1 way to organize it, and that's having no one sitting at it. That's why 0 factorial equals 1. So even though almost all of these with factorials are, 4 times 3 times 2 times 1, it really is just how many ways you can organize it. So that's why 0 factorial equals 1. You have to remember that 0 factorial equals 1. Think about that empty desk. How many ways can you organize it? 1 way, no one's sitting at the desks. We're going to go ahead to do this evaluate thing. This evaluate thing is important for you to know because I'm going to make you do these without your calculator. So you will not just be able to put add 8 factorial in your calculator over 2 factorial times 6 factorial, and I will give you huge numbers for this. So you have to know these shortcuts. So the first one we're going to do, we're not going to take any shortcuts. We're going to say, well, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I got it in there. Whew. 2 factorial is 2 times 1. We're multiplying that by 6 factorial. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Well, it's just a series of multiplications. So we can simplify stuff. I do not, in my head, want to do 8 times 7 times 6 times 5 times 4 times 3 times 2 because that doesn't sound like fun. So instead, I'm going to look at the fact that we have this 6, 5, 4, 3, 2, 1. And I have this 6, 5, 4, 3, 2, 1 down here. Well, those are the same numbers. So we're just going to cancel those out. They're going to turn out to the same number if I did the multiplication, so we're just going to cancel those out. Another thing you can do, so this is possible right now. This is just 8 times 7 is 56, divided by 2 is 28. It's not bad. There is one more shortcut you can do to simplify this, though. I can look at that 2 and that 8. I can simplify that fraction 8 over 2. So rather than writing 8 over 2, I'm going to change that 8 to a 4 over 1. Well, now I just need to do 4 times 7, and that's going to equal that 28. All right, let's shortcut this next one. I'm going to look at the top and bottom. So bear with me right now. I'm just going to write 2 factorial again. I'm just going to write 2 factorial. It's just going to stay there. I'm going to multiply that by 6 times, well, it's going to be 6 times 5 times 4 times 3 times 2 times 1. Rather than writing that all out, I'm just going to write it's 6 times 5 factorial. Do we all agree that 6 factorial is the same thing as 6 times 5 factorial? Do we all see that? Because 5 factorial is just 5. I'm just cutting out the middleman here. On the bottom, I can rewrite 3 factorial as 3 times 2 factorial. And I'm just going to write that 5 factorial again. Because even though they're in the factorial states, I can still say, well, this is the same number as this. So those are going to cross out. This is the same number as this one. So that's going to cross out. And all I'm going to be left with is 6 divided by 3, which just equals 2. So much easier than writing 654,321, 654,321, or trying to. Even, this is, especially with big numbers, this is sometimes quicker than even using your calculator, just seeing what's going to cross out beforehand. Because honestly, if you do this enough, you're going to see, well, this is just going to be 6. And you're going to see the 2's are going to cross out, so it's just going to be 3. You can actually visually see it. All right, this next question really gets to the heart of factorials and will tell me whether you fully understand it or not. So make sure you understand these types of questions, because I guarantee there'll be one on the test just like this. N plus 1 factorial, we have to know how to write this. It is going to be n plus 1 times. Remember, my next step is 1 less, and then 1 less. So n plus 1, if I want to go 1 less, is going to be n plus 1 minus 1, or just n. So it'll be n plus 1 times n. 1 less than n is going to be n minus 1. Then going one step further, we'd have n minus 2, n minus 3, n minus 4, n minus 5. I'm not going to write all that out, though. I'm just going to end at n minus 2. N factorial is going to be n times n minus 1 times n minus 2. Once again, it's just going to go on and on. The key part is this is the same as this, so those will cross out, and you'll just be left with n plus 1. No factorials, just n plus 1, so that is fully simplifiable. What I want you to do to finish class is I want you to go ahead and finish that problem on the left. It says list the first 5 terms. I don't want you to do the first 5 terms. Let's just go ahead and do the first 4 terms. We're just going to go ahead and do the first 4 terms. If you recognize the pattern, you can probably list the first 10 really, really quick. But I want you to do the first 4 terms. So just a reminder, if I'm doing the first 4 terms, there is no limitation of what n needs to be. So my first term is going to be a sub 1 equals. So you should have a sub 1 equals, a sub 2 equals, a sub 3 equals, and you should have values. Of our factorials. 0 factorial is 1. 0 factorial is 1. I pointed to it, and I said it was that empty desk thing. How many ways can you arrange empty desk? There's one way. So 0 factorial equals 1. Make sure you have this down. Make sure you understand factorials. Get your homework done. This is a very quick unit. So if you get behind, you're going to get behind really, really quick, because we're going to move on. All right, get it done. Check your answers. I will see